So when we're conducting binomial experiments, we need to follow the guidelines below. So the key concept we have, so step 1, describe a trial for the situation and determine the number of trials to be conducted. So this is going to be n, our number of trials. Define a success and calculate the theoretical probabilities of success and failure. So success, this will be little p, and failure will be Q. So describe the random variable. So this is going to be the outcome of the trial for X. And then design and conduct a simulation to determine the experimental probability. Okay, so our example: conduct a binomial experiment to determine the probability of choosing an even numbered card from a pack of 52 cards. Then compare the experimental and theoretical probabilities of the experiment. So we're going to follow the steps that we discussed earlier. So step 1, the trial. This is choosing an even numbered card. From a pack of 52 cards. So the number of trials we're going to use so the number of trials is going to be n is going to be 52. So step 2 is the success of choosing an even numbered card from a pack of 52 cards. Now, in a pack of cards, we have a diamond, we have hearts, then we have a club, and we have our spade. So something like that. And each of our cards, we have an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, and a king. Now an ace is worth 1, that's odd. So we want the even, so 2, 4, 6, 8, 10, and a queen, which would be worth 12. So that is an even number. So we're going to say that the probability, this is small p, of success. So this is success for an even card. So p, this is small p. So p is going to be equal to, now we've got 4 different suits. So we've got diamonds, hearts, clubs, and spades. So this is going to be 4 multiplied by, and we have 1, 2, 3, 4, 5, 6. So it's going to be 24 out of 52. So we could simplify this further, but we're just going to leave it as 24 out of 52 for a moment. So failure, so that's going to be getting the other cards or odd cards. So this is going to be Q, which is 1 minus P. So 1 minus 24 over 52. So this is going to give us 24 8 over 52. Now, we're going to do 52 trials, so we're going to just leave it out to 52. So step 3, this is the random variable, which is capital X, which represents the even numbered cards chosen at random from the pack of 52 cards. So, and the number of trials is 52. So we're going to use a random number generator on a calculator. A random number generator on a calculator. So this is going to be to create a simulation of the experiment. So to do that, we're going to do a table, and we're going to do a tally chart. So we want, this is our outcome. So our even numbers, so if we have even numbers, and this is going to be if we have the other numbers that are not even. So we need to create a tally, and then we can work out our frequency. So I have the Casio ClassWiz. So what we can do on here, we have the alpha button. So if you go to alpha, and then above the decimal point we have rand. So random here, and we're going to choose our numbers, and this is going to be between 1, and then we want a comma, which is going to be shift and the bracket, and the last number is going to be 13. Because we have ace to king, so that's representing 1 up to number 13. So we want to randomly choose our numbers, and as they come up, we're going to mark them off on our frequency table, and we're going to do a total of 52 trials. So press on the calculator. So the first one is 9. So 9 is an odd number. So this is going to be marked as an odd number. So equals, so I have 6, so that's an even number. 10 is an even number. 2 is an even number. 7 is an odd number. 10 is 5. And 3. Okay, so if we total these up, we've got 5, 10, 15, 20, 21. And 5, 10, 20, 31, which gives us 52 trials. So our experimental probability of getting an even number, so our P is 21 and our Q is 31. So this is out of 52. So P is 21, Q is 31 out of 52. So if we compare this, the theoretical probability and the experimental probability of our trial or choosing an even numbered card, so this being successful. So our probability was 24 over 52 for P, and our experiment was 21 over 52. So Q was 28 over 52, and Q was 31 over 52. So we can see we have 52 cards, and if we have 6 cards that are even, we're going to have 7 cards that are odd. So the probability of choosing an odd card is going to be higher.